Historical responsibility. The notion of historical responsibility is central to the equity debate and the measure of responsibility as a country's share of historical global emissions remains one of the essential parameters in so-called equity proposals, which attempt to distribute effort among countries in an equitable manner. The focus of this report is on the historical contribution of countries, but it takes one step further. Its general objective lies on estimating countries' contribution directly to the change in climate. The historical responsibility is not based on cumulative emissions, but instead measured in terms of the country's estimated contribution to the increase in global mean surface air temperature. In the context of climate justice discussions, the question of who is accountable for depleting the carbon budget is clearly relevant. It refers to who is responsible for dealing with the current effects of climate change, as well as who should be doing the most to prevent additional warming. A dataset of country-specific greenhouse gas emissions. In order to estimate the global temperature change resulting from anthropogenic greenhouse gas or GHG emissions, a consistent historical dataset of these emissions is required. In collaboration with the PRIMAP group at the Potsdam Institute for Climate Impact Research, an internally consistent historical emissions dataset has been compiled covering the period from 1850 to 2012 for all Kyoto GHGs and parties to the UNFCCC using the PRIMAP emission module and extending its functionality where necessary. In terms of cumulative Kyoto GHG emissions, weighted using the Fourth Assessment Report or AR4 global warming potentials, the USA is the largest emitter with 20% of total emissions, followed by the European Union or EU with 17%. China, Russia, India, and Brazil follow with quickly decreasing shares in cumulative global emissions. Within the European Union, Germany is a major historic emitter. When only considering carbon dioxide emissions, the EU and the US are the top emitters, with the USA leading with 22% of global carbon dioxide emissions. For methane or CH4, the USA and the EU have equal cumulative emissions, and for nitrous oxide or N2O, the EU ranks first with 17%, followed by the USA with 14%. For hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, the USA have by far the largest share in global emissions. China and India are the only developing countries present in the top 5, while Japan, Canada, and Korea also have relatively large shares. The country-specific emission pathways are created for the 6 Kyoto gases and gas groups, namely carbon dioxide, methane, nitrous oxide, sulfur hexachloride, hydrofluorocarbons, and perfluorocarbons. The PRIMAP emissions module combines data from different sources into a composite dataset to cover the widest range of countries, sectors, and gases. Sources are prioritized in order to ensure that the highest quality data is used. Where country-specific data is not available, growth rates from regional or numeric extrapolations are used. When creating the dataset, a sectoral resolution of the main IPCC 1996 categories was used. Category 1 for total energy and Category 2 for industrial processes are split further into subsectors as some of the data sources only cover subsectors of Categories 1 and 2. For each country, gas, and sector, data is first taken from the highest priority source. Data is then added from other sources subsequently using a scaling to match it to the existing pathway. Where no country or regional data is available, numerical extrapolation or global growth rates are used. For carbon dioxide emissions from the land use sector, a different approach was used. Houghton land use emissions data at the regional level is downscaled to country level using deforestation data calculated from historic land use data. To estimate the relative contribution of countries' historical GHG emissions to global temperature changes, the country-specific GHG emissions compiled and described in the policy-maker model was applied, which translates these historical emissions into global temperature changes for each country. The contributions to temperature increase in 2100 are then used as an indicator of historical responsibility. This table presents the contribution to temperature increase in 2100 of the top 10 countries plus the European Union resulting from emissions including land use change, and forestry.